Greetings, dear participants, and welcome to the webinar in preparation for the 2023 series of Technical Working Party meetings. Today we have the first webinar on selecting similar varieties of electronic tools. This is the first webinar on a series of 2 webinars to be held over the next 2 days. We're going to have an introduction for this first webinar, followed by presentations from UPOV members. A similar structure is going to be used tomorrow, where we will discuss another topic on involving breeders in the US examination with a short introduction, explaining or recalling UPOV guidance, followed by presentations from members. For the webinar today, we're going to have a series of presentations and only at the end, a session on questions and answers. So for those of you that would like to pose a question, please could you wait until all the presentations were made, and we will organize to answering all your questions. This session is being recorded. The video will be made available at the Technical Working Parties webpage. The session on questions and answers will be recorded, but will not be made available. This means that on the TWP web pages, you're going to have the presentations only. So just the videos with the presentations and not the video with the session on questions and answers. Tomorrow, we're going to have the second webinar, and same as today, we are going to repeat the same webinar twice, although due to time zone differences, some of the presenters may only make their presentations in one of the 2 webinars. So greetings and welcome participants to the first webinar on selecting similar varieties with electronic tools. The objective of the webinar is to provide basic information to enhance participation of experts at the Technical Working Party sessions. The first part of this webinar is an introduction, recalling guidance in UPOV documents in relation to document TGP9, examining distinctness. You have the web link where to find document TGP9 also from the UPOV webpage, www.upov.int. Under the tab UPOV system, you select TGP documents, and there you will find the list of all TGP documents, such as document TGP9, which I will briefly introduce. Document TGP9 provides a general overview of distinctness assessment. In particular, document TGP9 structures as a flow diagram the key aspects of different steps of examining distinctness. Document TGP9 also explains where to find further information for each of the different steps within the examination of distinctness. For the purpose of our webinar today, we are going to focus on certain aspects of the examination of distinctness from document TGP9, the flow diagram, starting with the notion of all varieties of common knowledge that should be taken into consideration for the analysis of distinctness, and moving on to the constitution and maintenance of collections of varieties. There are 2 steps that require narrowing down from all varieties of common knowledge to those varieties that should be considered more closely, and finally to certain varieties that may need to be compared, preferably on a side-by-side growing trial. The analysis of distinctness may then take place further down the line with other analysis for observing the characteristics and assessing distinctness in the growing trial. Supplementary procedures could then be used to publish the information and expose the authorities' decisions to peer review. All this information is encapsulated in document TGP9, but today we're going to focus at selecting similar varieties with electronic tools. So using databases or software for narrowing down from all varieties of common knowledge to those varieties that need to be compared for the analysis of distinctness. We have a series of 4 speakers, and I would like to pass the floor on to our first speaker, Ms. Valérie Outeval from France.
Okay, perfect. Sorry. So my name is Valérie Outeval. I work in France at GEVES office. I'm a head manager for DUS exam for maize and also for sorghum. And I manage also the registration of maize and sorghum variety on the national list. This figure is a summary of the DUS exam for maize. During the first years, we observed in the field the varieties candidate to make description of variety, to make uniformity and stability assessment, to make distinctness assessment, comparison side by side of peers indicated by breeders company. We make also genotyping, and at the end of the first years, we make a synthesis of data of description. And for us, it's impossible to compare side by side all varieties in the first years because we have around 5,000 inbreed line into reference collection. So at the end of the first years, we have a tools named Gaia. This software is a special software to compare description carried out on each varieties candidate between variety in the reference collection. And at the end of the first years, we can identify some variety which is necessary to make comparison in the field side by side. And in the first years, we continue the observation and the distinctness assessment comparison by side by side. So Gaia software. Gaia is a software for estimating phenotypical distances between 2 varieties and for managing reference collection. The aim of this software is to detect very distinct varieties, name distinct plus varieties at the end of the first years of the study on the basis of description made in the field in the first years. And also to detect the variety, the most similar, which must be compared in the field. The principle of Gaia software is the estimation of the morphological distances between 2 varieties based on the addition of difference observed for the different characteristics. And each difference observed is weighted by the crop expert according to the value of the differences and the reliability of each characteristic. So I have an example. For in maize, we have the characteristic type of grain. We can show that we have a different level. The note 1 is flint, and the node 5 is dense. And for example, we have the variety A. In blue, the node is 2, and the variety B, in blue, the node is 5. So the weight is 6 points for this characteristic between the two varieties. Another example, the variety A in red, the node is 5, and the variety B, the node is 4. And between 5 and 4, the weight is 0. Gaia make all these comparisons for all characteristics for each candidate variety in comparison to all variety in the reference collection. At the end, we added all weight for all characteristics, and we have a total. And the next slide is to show you that we have threshold on the phenotypical data. So in maize, we have a special rules. We use morphological data and also genetic data. It's the model 2. The first step is to calculate the morphological distance with Gaia software by comparison of morphological data between line in test and all line in the reference collection. The second step is calculate the genetic distance for each pair whose morphological distance is less than the threshold. In points for maize is 6 points. And at the end, we applied the genetic distance according to the morphological distance. So we can observe in the figures, the red part is all pairs distinct, so only with only morphological information. So the weight is equal or larger than 6. After we have the part with morphological distance less than 6, and we have two parts. The blue part is also distinct pairs because we have morphological information. The weight is between 2 and 6, and the genetic distance is upper than 0.2. And all pairs in the green part, it's peer to compare side by side in the field in the second years. So after applied Gaia software and rules for the model 2, we make in the field each peers identified by the combining phenotypical distance and genetic distance to make the comparison visually between the two varieties. Thank you so much.
Thank you, Valerie. Now we will continue on to our next speaker of today from Japan, Mr. Yoshiyuki Ono. Perfect.
Yeah, thank you very much. So, good morning, good afternoon, good evening, everyone. My name is Yoshiyuki Ono from Japan PDP office. Today, I would like to introduce selecting similar varieties with electronic tools. So, our database called VIPS, which is variety registration data integrated portal system. So we call our database for VIPS. So this diagram shows relation to our IT database with stakeholders. So applicant or title holder apply their variety by electric tools or paper documents. So our database VIPS file all applications, not only for electronic tools, but also paper documents. So that VIPS, the PVP office and NCSS connect this IT database to conduct the US examination. So all related stakeholders can access our IT database. So this slide shows user interface of our database. So I would like to explain about the advantage of VIPS. For examination operations, visualization of the work and sharing the examination status easily. And also easy access the several information whenever you want. The impact are shortening the examination period and keep quality US examination. So feature of recorded data in VIPS. So the VIPS has a matrix table of variety description and stored variety photographs. These elements are useful for the selection similar varieties. So here we have the screenshot of VIPS cross-search system from the matrix variety description table by state of the expression. So the rows arrange the characteristics and the columns arrange the state of the expression. So we can select a particular state of the expression of the characteristic by to narrow down the number of the varieties. Here we have the result of the previous search. So many of the varieties were narrowed down, only 2 varieties matched based on the selected state of the expression. And also we have useful link for the each varieties. Click here. So then screen move to the linked reference documents of the searched varieties. So we can see the application form and technical questionnaire and photograph of the examination. So if I click here, so you can see the photograph of the yellow ranunculus at the DS examination. So upper photograph was registered variety for the DS testing, and also we have the similar variety, 2 similar varieties here. So our IT database produce photographs and variety description. It means to enable selection similar varieties from combination with photographs and variety description. So this slide shows another function of our database, color search filtering function. So if we selected RHS 5A with a filter similar, the search result was RHS 5A varieties and 6A varieties. So our IT database will make a result not only precise RHS color code, but also resemble color, RHS color code. So conclusion for the selection similar varieties with IT tool, the visualizing variety, so that so intuitive variety selection and ensuring variety description, and also cross-search function is very useful tool of our database, being able to select from matrix table of the variety description and precise shooting of the target varieties in large numbers. So our advantage is keeping quality selection similar varieties, making efficient and optimization, and workload reduction. Thank you very much for your attention.
Thank you, Mr. Ono. We will continue to our next presenter from the Netherlands, Ms. Cécile Marchenet. Please, Cécile, you have the floor.
Thank you very much. Hello, everybody. I'm Cécile Marchenet, working at NACTAMBO as a DUS examiner in different crop, but in particular in French beans. So I will explain you today how we are using a special method to select on a genetic basis similar variety before the first growing cycle. This is, I have to precise that this has been a project for many years ago with a quite old method, AFLP, and now we are working on a new project with SNP database. So please, Leontino, next. So DUS test in French beans is very interesting with a lot of variety, but as you can see here, the list of all the grouping characteristics we may use to select comparing variety. We have a big amount of varieties, like about 350, all in the same group. So as you can see, they are all with growth type dwarf, growth type, white flower, round pods, green pods. And about the resistance, we have one resistant BCM&V is in the grouping, but we even use two other resistance, Colletotricum and Pseudomonas, to make the selection as small as possible. But even within those two resistance, we are still with a large group of around 200 varieties. And we got about 10 applications a year at NACTAMBO. Yes, please. So to go further with the selection, we needed to look to other characteristics than only the grouping characteristics. So here's some example, the leaf color, the size of the bract even, and some intensity of the pod. But you can imagine the TQ data are not always accurate, and it's normal because what's a 9, what is 7 for applicant, it's sometimes difficult. So that was the start of asking ourselves how to ameliorate this selection. Yes, thank you. So this test only based on this morphological characteristic was not always efficient. Because of this large collection, we have sometimes 20 or 30 comparing variety in the trial that cost a lot of time to prepare, to select, but also to compare very large trial. We would like to compare them side by side, but sometimes it's not possible. So very large trial with difficulties to compare application and comparing variety, and also a risk of mistake making this selection due to TQ could be not always accurate. So the aim was to make a pre-selection on genetical basis for similar variety before the first growing cycle. Because on this way, I will show you next please. Yes. So how it looks, we did already a selection of 96 bean varieties representing the whole genetic diversity on the genotyping by sequences analysis. We even include other growth type, for example, climbing beans, the whole collection. Then we optimize and validate, we are still on this step, the SNP set with enough distinctness power to segregate or identify the different variety. And at the end, we need the SNP profile for all the variety stored. So in total, we had 700 varieties in our database, and we did this work for 6 replicates for each varieties. And the aim is each year we will include in genotyping each new application and include that in this database. Yes, next, please. Here an overview what happened when we use this pre-selection. So it starts with showing the application before the DOS trial, just very short, maybe 3 weeks. Then DNA extraction, analysis with the SNP set, and then it's the first selection will be just on paper, selecting the comparing variety on genetical base. And we are now hopefully close to the 80% similarity, but this is even something we need to finalize in this project. When we make this first selection based on the genetical similarity, then the result of this selection will be given to the DOS expert to control, to check if there are not varieties selected which could be even more deleted from this selection, maybe based on a resistance which the SNP set would not have been detected. So that's the further work. Then we will show the first trial with only the selection of the comparing variety based on this genetical selection. Yes, next sheet. And the first time we will observe in the trial side by side will be only this first selection. We are doing then our own description of the application. And then come a very important control step. Did we miss something? So we go back to our morphological database, and based on our own description, which is mostly more reliable than the TQ description, we will look if we did miss some comparing variety. Is it sufficiently distinct from all the comparing variety? No similar variety needed. Then we can already, after eventually one growing cycle, make a positive report. Do we need another comparing variety? Then we will include in the second DOS trial the candidate, the closest similar variety from the first growing cycle, and eventually extra similar variety from the paper check step. Again, a side-by-side comparison and in the trial, and then is it sufficiently distinct? Then we can, and we have confirmation of the difference in both trials, we can make a positive report. Yes, next sheet. The advantage of this method is that no selection of reference variety based on the morphological characteristic provided by the applicant in the TQ before the trial. So we start with only the DNA profile. This is often an advantage for species with a very large reference collection. It reduces the cost and the workload. The pre-selection will be made easier. And the selection of comparing variety based on morphological characteristics will be based on our own reliable description. That's an important point. So the comparing variety that might be missed with the DNA selection in the first year are identified in the second year. Thank you. Yeah, next.
Thank you, Cecile. We will continue on to another presentation before we enter our session for questions and answers. So please hold on to your questions for the time being. We have our next speaker from New Zealand. I'd like to invite Mr. Chris Barnaby. Please, Chris, you have the floor.
Hello to everybody. It's nice to be back at a webinar. So selecting similar varieties, what do we do in New Zealand? One moment, please. Well, firstly, the selection of similar varieties always starts with the technical questionnaire. That is a very important tool, which is really the starting point of all our selection processes. No matter what they are, whether you use sophisticated techniques or more simple approaches, the key element is to begin with the technical questionnaire. That's the information that is provided from the breeder. And with varieties like ryegrass, we have a large number, as in the case, as we've already heard from the previous speakers, for maize and French bean and other crops. When you have a lot of varieties that tend to look rather similar, it makes it rather challenging for us to make any determinations over what is similar. So let's have a look at the tools that we have. The first one is that we have a case management system, and this was introduced a number of years ago. And all examinations are recorded in the case management system. And that includes the variety description for every granted variety. Now, unfortunately, the descriptions are not searchable in the system. That is something we are looking into for the future. The full description for every variety is in the system. It is accessible and it is available. And in addition, we use the UPOV model test report format, which indicates grouping varieties as well, to help with the possible use in identifying similar varieties. The case management system is also used for making applications. All the documents are stored in the system and includes photographs. Photographs is another area where we think we need improvement on storage of photographs and access. Just to give some perspective into where our case management system came from, we are part of the Intellectual Property Office of New Zealand, which also is responsible for other IP, patents and trademarks and so forth. And the system was primarily built for patents and trademarks. So we've had some work, continuing work, and there'll be more work in the future over the last 10 years into developing a system that suits plant variety protection. Our second look at electronic means of assessing similar varieties is use of a range of databases and spreadsheets. Now, these are managed by examiners. They tend to be species or crop types. Some are in Access and some are in Excel spreadsheets. So they're not particularly sophisticated systems, but they are very useful for storing descriptions, and they are easily used with simple filtering. The varieties in these databases and spreadsheets have all been DUS tested in New Zealand. In addition, there are partial descriptions with a focus on technical questionnaire characters for varieties in commerce, which are not protected, and are also included. I should add that New Zealand does not have a national listing system, so keeping track of varieties in commerce has its challenges. For some species, the number of varieties and descriptions are quite comprehensive, and for other species with few or infrequent applications, such in-house generated descriptions are somewhat limited. The database or spreadsheet can be filtered, as I said, according to the characteristics you wish to search on, which initially, of course, are the grouping characteristics from the technical questionnaire. It is important that these tools are kept up to date, and that is done as far as possible, and is a continuous process of expanding the variety list. It is possible to add descriptions from sources other than a New Zealand DUS trail. However, this is noted for obvious reasons, and if they are used for similar variety selection, that is taken into consideration. The databases and spreadsheets are a simple construction, largely utilizing elements provided in the standard packages. Examiners are, as I said, encouraged to keep them up to date and to add new varieties, particularly when recommendations are made for granting of rights. Now, another electronic form of database that we use, which may surprise some of you, is actually Pluto. Now, Pluto, of course, does not have variety description, but for species with relatively few applications globally, it can be very useful to see if there are other varieties at all, and if so, how many. Once these varieties are identified, these descriptive information can be obtained from the authority who listed them or from another source. And lastly, perhaps the ultimate electronic tool, of course, is the internet. And this is somewhat overlooked as an electronic tool, perhaps in the broadest sense, but it is a wealth of information. There are publications, there are journals, there are articles, there are business sites, as we all know. Using such information, of course, requires some caution and often verification from more than one source. Some of this cannot be said to be easily accessed, but it is there and the user can sift through it. The internet can also provide, as I said, could be seen as a giant electronic tool, and if used carefully and thoroughly, can provide considerable useful information. A particular feature, of course, are national authorities' variety lists and descriptions. Many of these are available to the public or with the login available from the authority. In many cases, the descriptions follow the UPOG model and are easily understandable and usable. And lastly, I just wanted to move away from the electronic world, and let's remember the non-electronic tools, and that is the examiners and experts. I think a lot of, we rely heavily on what is in people's minds. They are certainly essential as part of even any electronic system. And of course, in some, I've also heard them described as walking reference collections as one label that I've heard of before. So I think we should not forget about the role of examiners and experts in selecting similar varieties and the essential knowledge and experience they hold. And that concludes my presentation, and thank you very much.
Thank you, Chris. Now we will continue the webinar with the first presentation. We would like to invite our colleagues from Argentina. And for the presentation, I'd like to invite Mr. Alberto Ballesteros from Argentina. Please, Alberto, you have the floor.
Thank you very much, Lentino. I hope I've been heard correctly to everyone. First of all, congratulate to the UPOF office that always does an incredible things and very smart things to all of us. Congratulations, Lentino and Jessica, that you've been prepared this webinar meeting. Secondly, thanks to all the colleagues that are present. I hope to be fulfill your expectation. And I'm going to be brief to explain the basic thing that we know that we do in our PBR office in Argentina. So next, thanks very much. We have several tools at the PVP office in Argentina that we developed through the time, because we from 1935 we are dealing with differentiation processes in our country. But when we gathered in 1978 and 1991 or 1993, the 78 Act of the UPOF, we then started complying with the UPOF system. But in order to do the US test, we developed our own programs in order to make the things more easy, because at the beginning we start dealing with few varieties, and with few varieties you can do do it by hand if you want. But when the number of varieties is getting increasing in your systems, you have to start dealing with tools. I call tools the programs. We use another tools like tablets or data loggers, etc. But let me introduce you to the programs that we developed. First, we developed a DIF programs, which is basically a differentiation program that allowed us to differentiate the candidate variety with the old knowledge varieties. Then this DIF program was specifically designed for differentiate cultivars to all the species, because all the species has to be submitted by a form, a description form that contain morphological data, physiological data, phenological data. That could be transformed in a number data, and then we introduced the differentiation program, and the differentiation program allowed us even to every characteristic to open up in classes and to choose which is the most similar, when is similar or when is different. When it's different, it will mark with an asterisk. So when at the end of the program, when the program will do the report, it will sum the number of asterisks. So the most similar variety will not have any asterisks. So that varieties, we will put it in trails, and we let it from the trail we will pick up the data, and we will reload the diff, or we use another program. We are moving from the DF program to the Gaia. I will explain later the Gaia. Another thing that we do in our office, and which is very difficult too, is to deal with the denominations. Denomination, I think is part of the US test. It's not completely part of the differentiation, uniformity, and stability, but it's a very difficult things to deal, a differentiation of the name, what was denominations. our law required that the denomination cannot be delivered any error or interpretation, or that denomination could send you to another variety. So we developed a program was very specific with a number that count the number of vowels and consonants, and we give you that, and I give you the phonetic, of course, in Spanish, no? It gives you the phonetic, so it guides you if it's a new denomination is suitable for the variety. Concretely, we use this very much, and many times, help us to reject the denomination. Of course, we use the data, the UPOF database too. Next, please. With the time, with the number of varieties, and with the program we pick up from the to enforce the law in at the commercial matters, or the market matters, we start to use molecular markers. Specifically in three, we started in 3 different species: soybean, which is the major crops that we grow here in Argentina, and then rice and wheat. And cotton, sorry. Number of varieties, like 100 presentation or 200 presentation every year with 700 knowledge variety, it makes the DF programs overwhelmed. You spend days and days and maybe months to research and group in the more similar varieties. So we're dealing now with the molecular market. But in order to use the molecular data, the lab will give you a matrix, which is basically with the heterozygous and homozygous allele. So we have to transform it in numbers, 0s and 1s, and then to perform the Jacquard test. So to do that, to transform the matrix from heterozygous and homozygous allele to a number 0 and 1, we have to develop a program, a special program. It took us quite a lot of time to explain our people that work on the program, to explain how to do that, but finally we reached a very comfortable program that gave us not only the Jacquard distance index, if not really to use on Gaia. So the only thing what we have to do is just load it with the allele matrix. They perform the task and give us the simple column that we load the Gaia data. Another program that we use very extensively, that we did not develop this one, is NT6PC. When we took the plants and the fields, the most similar varieties on the field, we use many times the NT6PC to group in variety into the principal components, or to differentiate them to the phonetic dendrograms. That was the phonetic dendrogram is being used very much years ago to the botanic taxonomy. Or if you want to do a research, we do very much research on characteristics, for example, how related the characteristics are. We use these programs very much. Next, please. Well, the next program is the Gaia that we are implemented slowly, but we're implemented in many species. You read in there that soybean, grapevine, anise, hazelnut, sunflower, etc. And we will use it in rice and cotton. The Gaia has quite difference with the DIV on the morphological side, on the side that we deal with the characteristics. But the Gaia has this phenomenal progress that it could work with the molecular data and phenotypic data. That is very, very good idea, and I congratulate the people that Jeves France did it, because it helped us very much to find now with the molecular data and phenotypic data, to group the most similar characteristics, the more similar varieties, and in soybean, solve a problem by a 75%. So we have to plant only a small group of plants to differentiate. So and we are going to implement it in rice and cotton very soon, because we already finished it to genotype those two species. This is the end of the presentation. I told you I was a very brief presentation, but let me tell you that we are studying how to use the artificial intelligence to deduce that. We are at the beginning of the study, and how to use drones and other tools, which is work with images or image analysis. Well, that's all. I hope it's brief, but I hope everyone gets what we do at our office. Thanks very much to everyone.
Thank you, Alberto. It is beautiful to see cooperation amongst your members, where exchangeable software is being widely used to the benefit of all members. Our colleague from Bolivia, Miss Margarita Soto. Margarita, welcome.
Buen día, Leontino. Buen día para todos. ¿Me escuchan?
Margarita, please, you have the floor.
Bueno, yo les voy a hacer una pequeña presentación de lo que es el sistema que utilizamos nosotros en Bolivia para hacer el DHE, que se llama el sistema Optimix, que está basado en una base de datos Oracle. Puede pasar a la siguiente. Ya. Ahí tenemos lo que es el inicio del programa, donde podemos ver que la primera parte es el menú de parámetros, luego tenemos el menú de operaciones y el menú de reporte. En el menú de parámetros es donde ingresamos todos los datos esenciales. En el menú de operaciones ya les asignamos la función de cada uno, y en el menú de reportes ya podemos imprimir los reportes que deseamos sobre, en este caso, sobre el DHE. La siguiente. Ya, acá seguimos en el menú de parámetros. Ahí podemos ver los diferentes categorías que tenemos. Ahí podemos introducir primeramente el cultivo, luego ingresamos lo que son el nombre de las variedades. La siguiente va a traducir, disculpe. Ya. Acá ya tenemos lo que es para hacer la verificación del examen de HE. Ingresamos al cultivo, elegimos la variedad y hacemos la introducción de los datos que nos presentan en lo que es el descriptor varietal, que está basado en las directrices de la UPOC. Nosotros como Bolivia estamos utilizando las directrices de UPOC para la descripción de la variedad. Una vez ingresados estos datos, pasamos a la siguiente. Acá podemos ver que ya están el listado de las características que se está ingresando del descriptor de la variedad. Siguiente. Ahora vamos a pasar a la parte ya de reporte. Como podemos ver, hay una categoría que dice diferenciación. Pasamos a la siguiente. Ya, acá ya tenemos elegido, vamos eligiendo el cultivo, luego elegimos la variedad y después vamos eligiendo las características de agrupación. Acá tenemos hasta 5 características de agrupación que nos ayudan a seleccionar las variedades y poder hacer que se vaya achicando el número para poder hacer una mejor comparación. ¿Ya? Siguiente. Acá ya nos está lanzando un reporte de lo que son las variedades más parecidas en función a los caracteres de agrupación que hemos tenido, y las partes con negrillas son las que están marcando las diferencias que hay con las variedades. Siguiente. Bueno, acá continúa el cuadrito del reporte y al final podemos observar que tenemos el número de diferencia que hay con cada una de las variedades, ¿no? Que nos está mostrando al final. Nosotros, en función a todos estos datos que hacemos, finalmente, en la siguiente página, finalmente elaboramos lo que es el certificado de distinguibilidad. Van a disculpar, acá puse una foto de sorgo, sin embargo estamos hablando de variedades de soya. Entonces, colocamos al inicio quién es el solicitante, luego tenemos el cultivo, después el nombre de la variedad y qué tipo de registro está realizando, si es registro de variedades comerciales o es protección. Luego tenemos anotado cuáles son las características de agrupación que hemos utilizado y con las características de la variedad ya en estudio. Seguidamente tenemos las variedades más parecidas de ese grupo que hemos visto. Hemos elegido las variedades que tienen menor número de diferencias para poder incluirlas en el certificado de distinguibilidad. En este caso elegimos la variedad Azaí RG y la variedad Lealcén BO 637. ¿No? En función a eso vamos eligiendo las características en las cuales se diferencia, ¿no? Como podemos ver acá en Munasca, tiene hoja tamaño mediano, Azaí tiene tamaño pequeño, en Lealcén tiene tamaño mediano, pero tenemos en el abullonado de la hoja, en la variedad Munasca o la variedad candidata, es débil, en Azaí es débil, pero en la variedad Lealcén es medio. Luego tenemos la intensidad del color marrón de la vaina, que en la variedad Munasca es claro, en Azaí y Lealcén serían oscuros. Luego tenemos el color del lilio, que en la variedad Munasca es marrón claro, en Azaí marrón claro, pero en la variedad Lealcén BO 637 es negro imperfecto, ¿no? Esas serían las diferencias que hemos encontrado. En el caso de cuando vemos que las diferencias que se encuentran no son tan muy relevantes para decir que la variedad es distinta, nosotros llevamos a campo para hacer un ensayo de DH. Pero en la mayor parte nos basamos en la declaración jurada y se hace un DH sobre documento. La siguiente. Bueno, gracias. Esa sería la presentación. No sé si tienen alguna consulta. Ese es el sistema que nosotros manejamos. Bueno, sencillo. Gracias por su atención.
Muchas gracias, Margarita.